However, at the beginning of this year, our 10.11 series went long-term support for 5 years of that. And we're continuing the same pattern. Colin mentioned the the version numbering sort of jump. What we've decided as our process now is that, you know, after we release a long-term support release, we'll bump the major version. So the long-term support release is always going to be the major minor version below the big numbers on that. Damn it. My apologies, I'm going to have to try this again. Tiny.cc Maria TB Boss. Oops. Almost did it. Almost did. Don't stuff it up. Don't stuff it up. Hey. Except that. So. So to be a bit different from usual, I'm actually doing this presentation at Juniper Notebook, which was one of our developed features from one of our former staff members. If you want to follow on this tinycc/MariaDB FOSSASIA, will bring you up an instance where you can play with the running server. As before I said, you know, our GA started in 2011. So if we run that, and this is what I'm running in this test instance on this little cloud service. So new features, I'll run into them a little bit quickly. UUID is now a data type. This was added in 10.7. Strangely enough, it looks like a UUID. You can refer to it just as a text name there. You can insert things into it, and they come back as the text of a UUID. You can convert binary strings into a UUID, and you expect that. If you've got something invalid, you can expect it to fail and give a warning. Strangely enough, just what a normal data type is meant to do. So 10.7 is when we added that UUID data type. The other data type that was added is INET version 4. You may ask what happened to INET version 6. Well, actually, INET version 6 was added all the way back in 10.5. So a quick recap. There is an INET version 5, INET version 6 here. It can take IP version 4 mapped addresses and also IP version 6 addresses, as you'd expect. So what we added was INET version 4 as a data type. It, strangely enough, stores them and treats them exactly like a data type there with validations, as you'd expect. In MariaDB 10. Where was it? 10.10, I think we added this UCA collations. So historically, MariaDB has been on the collation standard of the UCA of 5.2.0. We finally updated to the latest collation standard of 14.0.0. Being a standards body, they seem to move quickly. It's now up to 15. Sorry, we can't quite move that quickly. But, you know, it was a major effort to get this collation work in. So what this means is these are all the new collations that are available. For those that dealt with MySQL collations before, there's a case insensitive and a case sensitive version of these. And what what is new is the AI and the AS, and that's the accent sensitive and accent insensitive versions of them. We'll see, like previous ones, there's a notepad and a pad collation depending on how you want to actually treat white space in your collations. So this is there for all the languages of the standard going through. Yes, there's a lot of them on that. And what you do is you just attach this to a UTF-8 type, and you've got your own collation there. Since 10.7, we've obviously been catching up with the world on using a lot of JSON functions. So there's this JSON equals, two JSON objects are equal if they're the same. If they're not the same, it returns false, which is kind of what you expect. To make things a little bit easier, we've actually made a JSON normalize function to bring the text of a JSON object down to a normalized form. And the useful for this is actually if you want to actually have a unique JSON object in your tables, you just create a generated column as jnorm here, and that's the normalized value of it. It's a virtual. We add a unique key on it, and what that means is that if we insert Alice with blue that way and try to rearrange it and do it insert again, we've got a duplicate key error. So that's one way to normalize it down. JSON Pretty is pretty much the same as JSON Detailed in MySQL, just creates a pretty version of it. And this was a quick community contribution that we received. Probably should list them a little bit more. Got a CRC function, was mainly added for a test case, but it's there for everyone else. Random bytes was also a user contribution from our community that wanted the same as the MySQL function, so that one's there now. JSON histograms, for those that remember back to the MariaDB 10.1 days, there was a move to have histograms there that represents the distribution of the data over a table. So what JSON histograms does is extends this syntax in the way that it's stored in the table to give better selectivity, particularly around those edge cases. As data changes from one string to another, gives a better granularity that way, and so you'll get kind of better queries. So here we create a table, we push a bunch of values into it, we run an analyze table with histograms with the JSON HB histogram type, and what we see in the column stats at the end, all the way at the end as this case may be, is just a histogram in a JSON format that describes the layout of the table, where things start and where things end. And obviously, as you move towards a bigger data set, this becomes a lot more significant on that. Another function, JSON sort key, natural sort key. Too busy in the JSON mindset. So natural sorts is, I guess, when you've got numbers and letters all in the same thing, you want the numbers to be sorted in a numerical order and the alphanumerics in an alphanumeric order. So we create a table, sort a bunch of things. If we didn't have a natural sort key, what we'd see here is that A2 came after A11, which doesn't actually mean not the natural sort of order that people may see things in. But if we do a natural sort key as the order by, obviously not the most efficient way to do it, what we see is the A1, A2, A11 coming out in that order. Some applications of this you may not immediately think of. If you want, say, IP addresses sorted, or anything with actually a bunch of numbers separated, you can make this to make sure the numbers, the IP addresses come out in order. Another useful application for this is if you've got version numbers in a table and you want them to come out in order, just do a natural sort key on that and they'll come out in order. Not sure why I did it twice. Maybe once is never the gun. For those who have played with large amounts of concatenation, string left, string right, and alignment, and trying to do arguably silly things like formatting in databases, we've made the sformat function there to make things a little bit easier. So this introduces pretty much a JSON kind of formatting function into the database, so you can format it there. This is based on the libformat library, which is going to be introduced into the C20 standard, but for the most part now it's an external library, and this will allow you to do things like use two values here and just pass arguments at the end. If you were to do that in previously, you'd end up with a bunch of string concat functions, possibly a bunch of cast functions. So now you just get it all pretty much easily there. And there's a whole bunch more features in the format, like left alignment, the things you normally see in printf anyway. Descending indexes, something that MySQL had for a while, but we finally got them, was if you're doing a sort where one index is in one direction and you're doing an order by that field and an order by the other field in the other direction, now you can declare the index that maps to that correctly. So you can use the entire index for the sorting rather than just part of it and relying on to sort afterwards. And yeah, a couple of query plans will get through that fine. Convert petitions. For those who have worked with petitions and trying to get a petition out into a table or a table into a petition, you may have seen these steps before. You have, from a table, you do an alter, we create a new petition, we remove a petition, we exchange it and drop the other one. Or if you're doing the other way, moving a normal table into a petition, you get the values and then you try to swap and exchange things before. What we've done now is we've created a simplified syntax where you've got one alters table variant to move a petition into a normal table and another alter table variant to convert a normal table straight into a petition with the constraint around the values in that petition. Cool. So that's, I guess, one simplification. System version tables, they were there since 10.5, if I remember, so it's a rather old feature. So what's the new aspect here is we've gained the ability with enabled system variable that you can actually insert into a table. So you're actually able to migrate data that might be in ordinary tables into system tables. So a quick recap on what system versioning is. If we've got a table, we see it's only got one column. It's got system versioning enabled. When we insert it into it, we've got these two magic columns, row start and row end, and they represent timestamps of when was that single value valid in that table. So here it was developed from the beginning of 1980 to 20 hours and 1 second later in 1980, it doesn't exist. So what you can do is you can query it as of 1 second into the interval, if the value is there. Anytime before it, it didn't exist. And so that's the advantage system version tables. You've got a concept that there's a current table and there's what was in the past, and you've got this extended as of syntax to query what was in the past. Query a password reset reuse plugin. Very simple plugin. Means you just can't set the same password twice. It regains a history on that for those that need that sort of compliance. Just keep in mind that while we add these things like plugins of password reuse, there's actually a plugin API for that, so you can actually develop your own plugins for password reuse. And all the way back to even data types. The data types is actually a plugin in MariaDB, so you can actually write your own data types if you were so inclined. There's a working community that's going on to make some of these plugins a lot more available by making wrappers in Rust, so you can write your own wrappers in plugins in Rust and get those into the server. There's a HashiCorp key management plugin, just like Pacona has, to integrate with the key managers, and this integrates with our freely available transparent data encryption that's been there since 10.0, 10.1, long time. And if it was installed on this machine, it would show up. Get Diagnostics is a mechanism that's sort of not commonly seen. If you've got a value and sort of have got like one value in, and you insert a value, you get a duplicate entry for the primary key. For this one, it's fairly obvious that it's the second one because that's the only value. If you had more complex, unique key constraints or otherwise, that it's not really obvious which one was have. So if you want to do some error handling, you can say get diagnostics, and we get, it was the second row number 2, that was the error handling. Function attributes, in, out are now function attributes, so you can make sure you're using your functions the right way. In most cases, there's a constraint about it being in a select that's not valid. Alter, Pandy's going to do a talk later, so I'm not actually going to cover this. He'll cover that a lot more later, but in the replication, that alter tables are pushed through a lot quicker. MariaDB binlog, I think there's a community contribution as well. Finally got all the arguments to support GTID data types. That was added in 10.10, so you can do a start position, a stop position, and use GTIDs in the full native way that you would have used binlog positions before. On scenarios, I guess you're sometimes frequently transferring a master to a replica or a slave and back. With the GTIDs, if you didn't know them really, really well, it was easy to get them mixed up. So what we've added is just change master, demote to slave, single instruction, hard to get it wrong, and that will just swap the positions around on it and enable it to become a replica. Grant to public, it's not the same as anonymous user. It means that every SQL user has access to the test in this table, which is fine. Read-only, we've split out the read-only from the super user, so it's a separate grant, and there's reasons you may want to do that around orchestration and management. For InnoDB and the underlyings, we've got a fast insertion. We've got the resize of, so the table spaces, you can do a number of them on a restart. And that's about all I've got time for. So yeah, there's a few things there, a few text searches, a bit better memory management, and a bit of auto versioning. So apologies for running late, and there's also some other UI improvements. So any questions or feature requests?
I have a question.
Sure.
You mentioned UUID types.
Yeah.
Are all UUID types supported, or is it?
Yes.
And is there a generator for them? So can you, if you use them as like in place of an auto increment, can you just drop that in and let them generate?
Yeah, I mean, there's a UUID function which generates a UUID version 4 type. The thing I didn't actually mention was in the way we actually store the UUIDs is pretty much orientated around a version 4 types, which means it's such that all the time-based things is all at the end, so you get a faster insertion if you do bulk insertions around that.
So those are UUID ones?
4.
Four.
4 is the time-based and the Mac-based one. Yes.
Deviates from MySQL and is not available in MySQL main.
How much of this is available in MySQL? I think I'll defer to some of the MySQL people here. I think random whites is there, some of the other functions, maybe some of the JSON functions there, but all the system versioning is MariaDB only. Correct me if I'm wrong. The petition swapping is MariaDB only.
The concept of these plugins and all the things we can do with extensions, is that something that's not available in MySQL?
Not sure. I think I'll give the same chance. Not sure as to how much they've historically offered. Yeah.
Especially the HashiCorp plugins and all, this and all not available in MySQL, as well as the system versioning tables. That is also not available in MySQL.
Yeah.
But most of the all other stuffs, it is almost 80% we can say, and 70 to 80% similar to what we see in MySQL.
Yeah.
Especially the system versioning is not available in MySQL.
I guess it's also important to note that things like system versioning are an SQL standard that we just adopted and implemented. There's a lot more in the standards that doesn't quite always make it to the implementation stage, as we've seen. Yes?
Is it possible to migrate from MySQL to? Is it possible? Is it still possible to migrate from MySQL to MariaDB or from MariaDB to MySQL? I mean, the compatibility with the new version. Is it possible?
Okay, it's possible to migrate MySQL 5.7 to MariaDB. Easy enough. There's probably a small number of caveats around. There's about like a small list of functions that aren't there that we'll try to correct if anyone points them out. Going from MySQL 8 to MariaDB, at the moment you'll have to do an SQL export and re-import. The way the innovation of InnoDB underlying on both sets is diverged enormously, such that you can't just move the data directory over and expect MariaDB to run on MySQL 8 at the moment.
Any more questions? Well, thank you very much for this wonderful presentation.
Thank you, Chris.
Kwan, who's going to tell us about making predictions using a heat wave in AutoML. At least that's my understanding. Welcome.
Yep, thank you. So thanks for joining us today. This is the third session, no, the fourth session of the Mars Scout Tracks. So my name is Ryan. I'm based out of Malaysia. So it's absolutely good to be back here in Singapore as well as FOSSASIA. So my last FOSSASIA session was in Bangkok like 3-4 years ago. So it's good to see some familiar faces. Okay, so I'm just going to talk about prediction, but just a quick, quick overview of MySQL. You probably have seen this in the keynote in my colleague's presentation. MySQL has been around for 27 years now. It's a very solid transactional database, and because of all this user, MySQL has gotten, it's been really rock solid and stable. And from the MySQL team, we have just added a great innovation into MySQL, cloud native, built for the cloud, HeatWave database engine. So this is what I'm going to talk to you about today. The cloud-based MySQL HeatWave engine. And not forgetting, lots of an open source application supporting MySQL that make it really, really popular. Okay, so MySQL HeatWave. It's one of the greatest innovations from the Oracle Research Lab that we have added a special plugin to the InnoDB engine. Bear in mind that this is a cloud-only database, managed database in the Oracle Cloud, as well as in AWS. And if you're running Azure, you can also take advantage of HeatWave using the fast speed interconnect from Azure to Oracle Cloud. So essentially, HeatWave is a special plugin to the InnoDB engine. As you know, InnoDB is very, very good in transactional workload. It's really, really stable. Customers have been telling us that the replication is rock solid. Without replication, you can't really do massive hyperscale application. And for that, there are certain things we still want to improve, especially on the OLAP workload, which traditionally doesn't really work really well in InnoDB because of the role-based RDBMS design. So what we have done is we have designed this InnoDB engine, the HeatWave engine, to be able to help you to automatically convert the role-based into hybrid columnar formats, and then making use of the elasticity of the cloud to scale the database engine for you. So this is introduced in Oracle Cloud in 2020. Today, we can scale up to 64 nodes, which means you can create a HeatWave clusters with 64 nodes in the cloud. And it's capable of building a data warehouse of 60 terabytes. So you can move 60 terabytes of your data into the cloud. So essentially, so when you have your transactional data, product, sales information sits in the InnoDB, you can push this data automatically to the HeatWave cluster. And data will be split and sharded, distributed into the HeatWave cluster. Okay, so in the columnar format, and when you run your analytic query, it will be automatically pushed down to the HeatWave clusters. And the data is stored in the memory. So you get distributed processing as well as in-memory processing to give you the power. Okay, so you can take advantage of the multiple nodes in the cloud. And one of the reasons why we choose to do this in the cloud is because you can scale up and down the resources, as opposed to if you run this in the on-premise, you would need to procure and buy server, as opposed to doing it in the cloud. So that gives us a lot of flexibility in adding new features and functions into the HeatWave cluster. Okay, so for the interest of today topics, I'll talk about machine learning. So machine learning is not something new, right? So every day we've been using the apps, Facebook, Grab, or Uber, right? So you can see that all these apps really make our life easy. Right? For example, go to Facebook, you see, the news feed from your favorite friends, things that are important to you, pops up in your news feed. And that's all because of the machine learning model, right? In the Macquarie talk yesterday, they talk about how they use the machine learning to do learn to ranking, is to move those content that matter to the user to the top. So that's essentially what people are doing today, right? Using machine learning to help build an intelligent system. Booking.com, right? So in recommendation system, so that people can quickly book a package, on Booking.com. So they want to turn clicks into sales by having this, recommendation system. Also, Uber Eats, to be able to send you notification, the right one at the right time, at the right user, to the right user. So all these are done using machine learning. And if you are in a different industry, there are many different cases, banking, the fraud, retail, telco, and other industry. I'm just going to fly by this. So just last week, coming to here, I received this SMS. I'm sure you receive all this SMS as well, right? So this is obviously a spam, right? So it, can you see? So it's to say thank you for your payment for Tommy for this 2,000 ringgit. And very quickly, by looking at this, this is a spam, right? Because it is a personal mobile number, right? And the language is not, properly structured, and the contact number is really not really a contact, the bank official contact number. So this can be a good use case for telco. So every day, we see all this, and machine learning is going to help us. But it's not that easy to implement machine learning because it takes a highly skilled person to do it, right? Data scientists, you need a person that's really good with Python, really good with machine learning algorithms, be able to get the right data, structure the data in a way that are good for learning. So these are the 4 machine learning pipelines that is common to all the machine learning tasks. And in order to get a tuned model, you really need to do an iterative way to get the model right. And that's not very productive, especially if you have a lot of data and you need to come up with a model in good time. So that's okay. I have a quick demo here. So this is to show you how a typical machine learning process look like. So you're going to have a data in the data frames, and then you would build a model, right? And in here you need to choose a model, right? The right algorithm for the data set, so that it makes sense to come up with the model that you like. So I'll just go through it. And you see that in the model, there are lots of parameters you need to tune in order to generate an accurate model. So that's typically how you would approach a machine learning with a traditional machine learning pipelines. So in HeatWave, we are automating this tedious machine learning task into AutoML. So this is an Oracle Research Lab technology. So it instead of you doing all this tasks, we automate it into the AutoML engine. And with that, we don't really need to have very high Python skill, but leverage on the SQL knowledge you have. So you can use SQL to invoke AutoML to create a model. So these are the 4 things that we innovate and put it into the AutoML. Number 1 is that in the pre-processing, we'll make sure the data set is complete, And the second step, is to be able to sample the data into a good size for training. The goal is really to come up with an accurate model in a short amount of time. And third one is we have a proxy model that we can start with. Instead of iterative, getting this model, we actually have a proxy model to start with and fine tune along the way to get to the tuned model. So with that, we have the engine within the heatwave database to allow you to do machine learning. So these are the 3 algorithms or 3 different type of categories that we support right now: classification, regression, and forecasting. Soon to be available is the anomaly detection, which is going to be available very soon. So you can tackle different problems using all these algorithms. And yeah, so if you work with scikit-learn, these are the algorithms that we support. And if you run AutoML, the engine will pick, depending on the categories, which algorithm will give you the most accurate in the shortest amount of time. So putting this together, doing machine learning in the heat wave, it is really having a set of data loaded in the heat wave engine, and essentially 4 SQL calls to implement machine learning in heat wave. So you can see that there's a ML train. There's a scoring for you to test the accuracy of the model, and then loading the data into the heatwave cluster, loading the model in the heatwave engine, and then depending on whether you want to do it in a batch way or in a real-time prediction, there are 2 different functions that you can use. Essentially, these are store procedures that you will invoke on the heatwave. To be more detail specific, these are some of the commands that you can use. Right? I'm not gonna go through each one of this, but if you're familiar with SQL, this is just fitting the value into the parameters. Predict table, explain row. I'm going to talk about explain a little bit so that the explain function is very important in the machine learning model. Okay, so I just want to run through a few illustrations to show you what happened in the backend. So when you have the data loaded into the InnoDB engine, when you execute the ML trained, the data will be loaded into the heatwave node in a cluster, and then the training would happen in the heatwave node. And once the the model is trained, it will then store into the model catalog, and then you can start using the model to predict by feeding it a new data set. Okay, so yeah, so when you run predict table, you will get the model from the model catalog, load it into the heatwave node, and then they'll get the result back to your application. Okay, same goes for the explanation. Again, the model will be loaded, and you will explain why a prediction is made in a certain way, so that it tells you what are the significant features that is used to making that prediction. Okay, so yeah, so because this SQL base, you can actually reuse, or you can use any of the notebook, Jupyter, Zeppelin, or any SQL tools to work with heatwave machine learning. Okay, so I have an application developed here that shows you how you can use this. So there's a banking marketing data, which the model is trained to predict which of the customers is likely to subscribe to a new product, right? So that gives the call center a good list of potential customers going to sign up because they can turn the potential into a customer, so that you get the maximum return out of the call center. So the model has been trained, and all I need to do is just to load the model into the cluster, and then I could show you the explanation capability in HeatWave. Right? So when you do a show model explanation, it tells you, okay, for this particular customers, why does it sign up the product? It's because the call duration, with this customers. And you can see that, oops. Let me just backtrack a little bit. Okay. Yeah, so there's other parameters such as the bank rate, the Euribor rate, and also the number of years this person is employed is important, making this prediction that this customer will sign up with the product. So with this information, the call center can pick and choose, the customers that will get likely to subscribe with the product. Okay, just roll forward a bit. And in terms of scoring, you can score. You can check the accuracy of the model, and there are many different type of metrics you can use to check the model. And here you could, run this prediction in Bash. For example, I'm creating a random table, and I run the model on this table, and it will give me a prediction whether which customer is going to sign up with the product. Okay, so let me just go to the next. Okay, so putting this all together using the actual SQL, you have a idea of how easy it is to use this in HeatWave. So I'm just connecting to HeatWave clusters, and this is the same data set that I show you. Okay. Right, so connected, and these are all the model in the model catalog. Yep, and yeah, so I'm just going to load the bank marketing model. So it's loaded, and this is the the prediction on the table. Yeah, so you just specify that the test data set, the model which is loaded in the HeatWave clusters, and the table that to store the result. So that's how easy it is, to use the model with SQL. Okay, so we also did a benchmark against others. You can see that because the in-memory clusters and also the AutoML technology, we are way faster than Redshift ML. And in terms of cost, it's just 1% of the cost of using on Redshift ML. So with that, very quickly, I'll give you a quick overview of what you can do with HeatWave. Besides, it's a very fast OLAP engine, but also you can run machine learning on HeatWave. And if you want to try out, because this is on the cloud, you can actually sign up on Oracle Cloud with a trial account. You get $300 or $500 sync in 30 days, or whichever come first, to try out the HeatWave and machine learning. So with that, thanks for your time, and I'm here to ask questions if you to answer questions if you have any.
I see a bunch of questions. So I'll go here first.
Hi, Cool Technologies. So how much influence do I have on the architecture of the model itself? If I say, okay, I want this many layers, I want skip layers, this many layers, and so on. Do I have any more influence than just say, okay, I want a classifier?
So the question is, how many different type of algorithms or? So today we support classification, regression, and forecasting, and anomaly detection is coming. So yeah, the list of the algorithm, it's pretty much those three that we have currently.
And we're talking about model training, but then how about model serving? So I see that this is like a very notebook-driven environment, which is great and all for prototyping, but then for actually putting this model into production, how does that work?
Okay, so it's all SQL driven. So once you have the model, it stores in the model catalog. So in order to consume the model, you need to load the model into the heatwave clusters. And in terms of the application, it's just a simple SQL to invoke the model to do prediction. So either you could do a batch kind of predict on the table, or you could do a row-based kind of prediction. So it's all through the SQL. So in your application, PHP or Node.js, use a MySQL connector, connect to a heatwave clusters, load the model, and then run the stored procedures for prediction. Yeah.
Sorry, I have an architecture question regarding how this works. Are you actually doing the querying and the model training separately, or are you actually able to do some form of distributed training on a cluster of having one of those cluster systems basically?
Right. So heatwave is a cluster system. So when you run the ML train, so it's actually distributed into the cluster node and then do training because data is distributed. So you do distributed training.
So
it's all done by the heatwave. It's all done by the heatwave automatically. So, yeah.
all right. Time for one last question.
So will this be published to open source, or how much of it already is?
Good question. This is not open source. Yeah, this is only in the cloud. So that's why you can try out the heatwave with a trial account.
All right. Well, thank you very much for this wonderful talk and answering all these great questions.
Thank you.
Thanks.
Thank you.
To talk about MySQL architecture and how to get the best performance you can out of MySQL. Thank you.
Hello, everyone. Okay, so I'll talk about MySQL architecture and my experiences, because I work as a support engineer, and I went through a lot of cases where customer faced challenges, different kind of challenges from migrating 5.7 to 8.0. And as you know, like we had 5.7, when we moved from 5.6 to 5.7, it was, I would say, it was not major change as compared to moving from 5.7 to 8.0, because there are a lot of changes in 8.0. Even though it is released as a minor release, there are changes that can break things. Okay, I would say, if you don't pay attention. So yeah, in this talk, expect that if you are using MySQL 8, or if you are planning to use MySQL 8, and I'll talk how you can upgrade, how you can optimize it, and few ideas on how we can scale using the feature which are available in MySQL 8. Okay, so I'll start with the MySQL architecture, and then we'll focus on the areas which are changed in MySQL 8. But let me go through the architecture overview. So when I say MySQL, basically InnoDB is the main storage engine. So I'll start with the InnoDB. So in a memory area, we have a buffer pool and change buffer. These will take care of your insert, update, whatever changes happening. It will happen here in the memory area. Then we have adaptive hash indexes. It is used for in-memory indexing, the hash indexes. And we have the log buffer, which will buffer the entries for read log, and then it will write to read log on the disk. Then on the disk level, we have the system table space, and here we have the major changes comparing to 5.7 that I'll discuss. But in 8.0, the only thing we have here is change buffer if you don't choose to store your data and indexes in system table space. Okay, by default, it's stored in InnoDB. We have a setting called InnoDB file per table, which is by default enable. That means whenever you create a table, your data and indexes will be stored in the individual table space. So if you have million tables, you'll have million table spaces. Okay, and it works fine. It sounds if you're using Oracle, then yeah, it sounds weird, but yeah, it works fine here. Then we have a double write buffer, which was part of the system table space earlier, but now it's moved. Then we have general table space and InnoDB file per table space. They were already in 5.7, so there is no change. But there are major changes when we talk about double write buffer, undo log, and temporary table space. Okay, so these are the major changes in the architecture. So this is how these are the components of MySQL. The InnoDB storage engine. Okay. So let's see how my data directory will look like if I install MySQL 8. Okay, the first change you will see that the bin logs, okay, which was not enabled in 5.7, in 8.0, bin logs are by default enabled. That means you'll get that, and it's supposed to be on in production. But if you're using a replica, in some cases you don't need binary logs. Okay, in that case, fine. Then we have the double write buffer files, which are created separately now. Earlier it was a part of system table space. Why this double write buffer file? Why we use this file? We use this for crash recovery purpose. So for example, if my MySQL crash, and while recovery, MySQL need the good page, whatever data committed, it need a copy of the good page. It will be contained in double write buffer as a safety mechanism. If you are using a storage like a Fusion IO, in that case you can skip it. Okay, but yeah, by default it is it will generate these files. Then we have the new redo-log directory. It is introduced in 8.0.30, which is very recent. Okay, so earlier we used to have two redo-log files by default, but now we have the separate directory, and I'll talk about it more in next slide. Then we have new session temporary table space. For example, if I am running a query, optimizer need to create some temporary table for some kind of operation, sorting or these things. So yeah, those kind of operations will be managed by this table space. And the very interesting change is the data dictionary. Okay, again I'll talk in the next slide. Okay, what it is, but it is purely created for the system table space. This is the major change, I would say, in a 8.0. Then we have our undo logs, okay, which are separate from my system table space. Okay, so again in 5.7 we have undo log in the system table space. If you don't explicitly create separately, and once you start your MySQL, you cannot change it. That was the condition in 5.7. That means you cannot move the undo logs. But in 8.0, it's by default they are separate. Let's talk about the data dictionary, because that's the major change. So this was the condition in 5.7. That means you have your metadata files, you have MyAsm tables, you have InnoDB tables. So there is a mix. Okay. So but in 8.0 we have the transactional data dictionary to store the data system tables, and that's the major change for the data dictionary. Then we have the undo logs. So for undo log, there is a feature for automatic and manual truncation, and you can drop and you can create table spaces like this. Okay, these are some example and the variables you can explore. For temporary table space, earlier in 5.7 there is only one table space, that is ibtemp1, but now in 8.0 we have the temp directory which create temporary table spaces like this for a session and the optimizer. For redo-log, in 8.0.30 there is a variable actually, but the new variable introduced, that is InnoDB log capacity, which supersedes the InnoDB log file in group and InnoDB log file size. So because of this, you have the redo-log directory, and inside that redo-log directory there are 32 files, and out of them some are ordinary and spare files. So ordinary is which are already used, and the spare, which means they will rotate, or the data will be filled soon. Along with that, there are some new features like redo-log archiving, disabling redo-logging, and redo-log encryption. This disabling redo logging is very dangerous. Okay, you should not do it no in the production. The one use case I can say is, for example, if you are loading the MySQL dump, that time you don't want to have the redo log, right? You don't want to write those things in a redo log. In that case, we can disable and your dump will be faster. Okay, data loading will be faster. So that will be that could be the use case for this case. Binary log, yes, these are by default enable, and now we have server ID is equal to 1 if you don't mention the server ID for your server. So these are the default changes. The term master and slave is a change in 8.0.26. Now they call source and replica. Okay, I think everyone, all organization aligning with that. So that's the change. But replication was a single threaded till 8.0.25. In 8.0.26 by default, replication create 4 threads, and your replication will be multi-threaded. Okay. So why these changes are important, because I have seen for a customer where because of this setting they experience some problem. Okay, and that was a buggy behavior, but they could not know. They were confused why it happened, okay, suddenly, and then we came to know that yeah, by default they upgraded, and by default their application is multi-threaded. So yeah, that's the reason it's very important to know check those things. Yeah, it is a positive one, okay, but the thing is, in that case the behavior was buggy. Okay, that bug is fixed. Okay, so I would say it's a positive. Okay, having a multi-threaded replication. Yeah. The tools we have in MySQL 8 is MySQL shell and MySQL upgrade checker. So MySQL shell is basically used for right now. If you're using a MySQL cluster, it will be a part. This tool MySQL shell is a part of that tool, and you can also use to query your database. So I would say it's kind of a you can use all-in-one tool, okay, rather than using only MySQL client. So yeah, this you can use. MySQL upgrade checker, if you are upgrading your MySQL and you would like to see what are the changes you have in your database. For example, if you are upgrading from 5.7 to 8.0 and you would like to see if you have any deprecated options, any character set issues. So there are 20 plus checks it performs, and you'll get a summary that before upgrade what is the problem and what issues you should address before moving to 8.0. If you are using a Percona server, we have add-ons like this, which is completely free. We have an audit log, thread pool, data receipt encryption with the keyring vault. You can use a HashiCorp with it. Data masking to mask your data. Pluggable PAM authentication plugins, and some there are extended functionalities. For example, the verbose information in slow query log. So these kind of features you will get if you are using a Percona server for MySQL. Okay, the server level features are same. MySQL we are always compatible with the upstream MySQL. You can have your source as a Percona server and replica as a MySQL, no problem. Okay, so it's fully compatible. Okay, things you should look out when you upgrade. Read document. This is very important. I know it's boring, but yeah, it is must. Even if you're doing a minor version, please do it. The default changes and dependency in your environment. For example, character set. This is the problem I have seen many times. Customer has a Latin character set in 5.7. They move to 8.0, and while querying, they are getting some different data output, some different output because of client and server character sets mismatch. So yeah, you should look that. And how we can solve this problem? Using the MySQL checker, because it checks that thing. And there are a lot other things also. Remove and deprecated variables like InnoDB temp storage engine. Okay, like then MyAsm is removed. Earlier it was MyAsm, so now it's InnoDB. So yeah, as I said, use this utility. It comes with the MySQL shell, and yeah, look for the change terminologies. And finally, once you do this type of checks, do the performance benchmarking. Okay, and you can use a monitoring tool to see the time series data. For example, with this setting, how much IO it was using, or MySQL related stats you can compare. Now the important configurations, okay, let's talk about it. There are 600 plus configuration. It's difficult to say which one to configure, but I can, that's the reason I did this, I you know, divided section wise, so at least you can know, you can focus in which direction you should look, okay, if you want to optimize. So for example, use of table spaces to store data efficiently. So for example, you can have your undo table space, okay, depending on the amount of undo operations performed in your environment. You can use general table space, which is, for example, let's say you have 100 clients, rather than storing each table in individual table space, you can create 100 table space, one table space per client, okay, and you can store all tables in that table space. So that kind of a use case you can do. Binary log locations, rather than keeping on same mount point, you can keep it on separate mount point, so that's how you'll get good IO, performance, okay, rather than keeping in the same data directory. Use encryption to secure your data, because all these table spaces and all these files are available for encryption, so you can do that. And the OS resources, for example, you can use which malloc library you want to use, okay, disable the huge pages, okay, and set the correct NUMA control, then set the swappiness, okay. So these kind of configuration you should do on OS level also, because when we run out of when we optimize database side of configuration, and even after that we are facing a problem, then you should look this side as well. So these things. On InnoDB side, these are the list of variable. I would like to focus on the important one, which are InnoDB flush method and InnoDB flush transaction at commit. And okay, so these variable can change, okay, how this variable can trigger the performance issue, and also they can solve the performance problem, okay. So yeah, these are the some important variables you should look. And the third, it is a part of a configuration, because whenever you face a problem, you should check, you should know how to find a problem, okay. And for that, MySQL comes with a very good enhancement when I say performance schema, because it's time to time I have seen lots of improvement in performance schema, and it is very useful to troubleshoot the problems. Log verbosity, this is very important. In 5.7 you used to see the error, the notes as well, okay, the normal messages, error and warnings. In 8.0 you will see only warnings and errors, no notes, okay. So if you want verbose log, you need to set that option explicitly, okay. So those are the some debug and monitoring tips. You can use a slow query log, okay, and the audit log, okay, for the troubleshooting. Now let's talk about, this is the final thing, how you can scale, okay, what are the scaling solution you have in 8.0, and what you can do to scale your workload. So earlier we talk about the vertical scaling, right, configuring and optimizing variables on the same machine, operating system configuration, resource configuration and all. But now once you're done with the vertical scaling, how you can scale it horizontally. So let me talk about the read scaling. You can use the traditional replication, that is source and replica. The another good option is group replication, okay, and you can use, on top of that, you can use HAProxy or ProxySQL, okay, to load balance and do the routing of your read write load. Then the InnoDB cluster, the complete package which comes with, so InnoDB is built is a set of group replication, MySQL cell and MySQL router, okay. So these things. And finally, PXE, you can again use with HAProxy and ProxySQL. For the write scaling, I would say it's not a pure solution. I would say it's kind of a primitive sharding. That means you cannot write on multiple nodes at a time. You'll see a lot of conflict issues. But there is a hack, there is a workaround. Not a hack, but I would say you can do it using the ProxySQL query rule. Okay, so you can use the ProxySQL and you can divert your load depending on in which table on which host you would like to write. So that kind of thing you can do. Geographically distributed. For example, one example, let's say we have a dating app. So yeah, I'm in Singapore. So yeah, I can have one server in Singapore and I can have one server in, let's say, Europe, okay, maybe in London, okay. So I'm sure that local people will look for search for local region. So I can have one server to for write there and one server here in Singapore, and that's how I can write at multiple places. So it's more like a application based, okay. That is also possible. Then there are few options, pure sharding options. For example, NDB cluster. It's a it can it can scale your writes by doing horizontal scaling, and there are other solutions that like Vitesse. So they provide write scaling solutions. So yeah. I added some references. You can I'll give this slide so you can refer. And if you want to know more about once you test or once you benchmark, how you will analyze the performance, we have the tool called PMM. So tomorrow we have talk on that. So using that you can have a different kind of graphs for MySQL. It also supports the MongoDB and PostgreSQL and operating system monitoring, but you can use those graphs to analyze the performance of your database by changing various options and how it performs. Okay, so that's all, and then thank you, and yeah, question from me.
So your first question here.
So general question, is Percona now just providing patches to upstream MySQL, or do you still do your own engine as well?
Good question. So we fully compatible with upstream, okay. So whatever bug any community user reports, we fix, or the upstream fix, and we offer the patches. It's up to them whether to accept that or club it. But yeah, I have seen a lot of the time they accept, and we exchange our thoughts. So, yeah, it's fully compatible.
Okay. Are there other questions? Otherwise, I have one. Okay, I'll give my question and then I'll bring it over to you.
Yeah.
So could you describe for me, you mentioned tuning huge pages. How does MySQL use huge pages, and how does this affect performance?
So I don't know much about it, but usually the recommendation is disable it. I have few good reference blogs that I can refer or I can share and I can discuss with you. Yeah, but yeah, that's the thing.
Hi. Is the replication synchronous?
Okay, so there is asynchronous replication, there is a semi-synchronous, and there is a virtually synchronous. So it is not fully synchronous. Okay, so that means, for example, if I have two nodes, one node will write it locally, okay, and it will ask other node, is it okay if I commit it? And other node say yes, it's okay, but the other node will write that thing maybe second later or something like that. Okay, so it's kind of a it will write for sure, but it's like a virtually synchronous, not at the same time. Yeah.
Okay, next question. Okay, great talk. I enjoyed it. I think we all did.
Yeah.
And yeah.
Yeah,
I
I would love it. I mean, I just shared what I know, but
Yeah.
if you guys know any use cases and if you'd like to discuss, please let me know.
Sure.
I'd be happy to discuss that. Okay.
Yeah, thanks.
Thank you, everyone. Disconnect.
Just 1 second. Okay, so next we have Tommy Chung. He's going to tell us about his roadmap towards building an independent open source distributed database. He's from the ocean-based team. So.
Well, thank you very much. So today we're actually talking about our open source distributed database platform. It's ocean-based. So before we start that story, we really want to look at why we decided to develop this database. In fact, necessity is the mother of all inventions. So yeah, for some reason I know why. I think accidentally deleted something. Hang on a second. I'm so sorry. That's weird. It is there. Oh, it's back now. So, we were looking at explosive data growth. So when we say explosive data growth, you're looking at the likes of e-commerce, like social media stat. In the next 2 years, we are going to reach about 132 zettabytes of data globally. Another thing is, if you're running e-commerce website, you're running something like Taobao, you're running something like Lazada, Shopify, Shopee. One of the challenges is there's a massive amount of data volume. So the massive amount of data volume comes in many different factors. One is, you got product data, you got metadata, you got customers doing feedbacks, and then you also got to handle the transactions. And nowadays, if you use a platform like Lazada, you use a platform like Shopee, you realize that every month or every now and then they come up with some promotion offers, right? Of course, the most popular one is W11, right? In fact, the origination of this database, when the company finally decides to say, okay, enough is enough, we need to find some way to deal with this, it's actually W11, where one of the commercial databases that we were using 12 years ago killed over and caused a lot of pain. Another one is also like a stronger capability to handle the kind of data growth that you have. Traditionally, the
we call it monolithic database, but it's just how the database was being developed, right? So when we started to have the concept of database, we started with the mainframes, and then the mid-sized systems like AS400 and so on, and then we developed into the PC era, where you start to have machines more like commodity hardware, like where it's running Linux. So Linux actually is the start of the revolution, and that's why I'm very happy to be at the open source platform where, when I started my IT journey, I actually started with Red Hat Linux version 1, right? And in that time, the database model is like, I want to find some way to store data. And it's not that much of data we want to store, because during that time, the computers are not that capable. The memories, the storage, we're talking like 80 megabyte hard disk. That's what I remember, right? That was a really, really long time ago. So going from that perspective, the traditional solution is that I make it as I can just have bigger and more performance systems, but eventually you hit some kind of roadblocks where bigger is not always better, right? Another thing is, then you have another solution is that, I used to work for Oracle as well. Oracle says, okay, I can make it scale, but in some sense, it's still monolithic because, compute, I can separate it. So what Oracle Real Application Cluster means is that you can have a cluster of systems, but your storage is still shared, right? Your sessions information is still shared. Your memory state is still shared. So you still have some kind of limitations. Of course, you have machines like Exadata, which is very, very capable, and they can scale to handle petabytes of data, but it's a really expensive, customized hardware solution. And of course, then you have sharding, right? So a very good example of sharding would be the likes of DynamoDB from AWS. I used to work for them. Is a kind of sharding that you do is you use a hash key, and you specifically use algorithms to shard your data across a number of systems, and you can split them and partition them as much as you want. But still, in order to do that, it's a bit of a complication that you have to actually manage that yourself. So from that perspective, we think about this as more like a distributed requirements, that eventually you need to distribute your data. You need to expand the way that you're going to store your data. And not only that, is that you want to find, we're still doing like partitioning, sharding of data and so on, but you want to like also automate it, and you want to have the ability to not just like doing read-write on one particular or cluster machine. So for some of the systems in the market, yes, you can do scaling, you can do horizontal scalings. Like take AWS Aurora, for example, you can scale it horizontally. They have a shared storage system, but there's only one instance of read and writer, right? So you have one massive, large read writer, but you have a lot of readers that you can use to scale your requirements, right? So for read only, you can scale it to quite a bit of a size, but for the transactions that you're writing into the database, right, you still have one single instance to do it. But of course, then you have other systems like, you start to have someone like Google Spanner, which is kind of in a very similar concept where now you can spread it into like multiple systems automatically, and you can really span it into different regions as well. I'm sorry about that. Okay, so the pain point for us was, we have a performance bottleneck. We really want to scale, and the challenge here is that because we want to do the scaling, we needed to be distributed. We need to scale very fast and on commodity hardware. Another one is that we need to eventually now we also think about, customer says not only want to do the transactional. So this is the chicken and egg issues all the time. Customer says, I want to do transactional, and then suddenly they say, I also want to do analytics. So at the moment, you do it in two places. But for us, we try to say in the same instance of schema and data tables, you can do the same now. We can locate. I have to go faster now. Yeah. So just to go very quickly on our evolution, we started in about 12 years ago. We started with Taobao. Right, we decided to really have this self-developed distributed architecture initially supported Taobao, eventually we also supported Alipay. So now if you use Alipay, you use Taobao, the database backend is actually ocean-based. And also if you look further forward, and then we start to have our partners, our financial partners, they said, this is great, you can do like massive distributed transactions, financial transactions. We really want to use it on our own business as well. So then you have also the banks, the brokers, and even insurance companies started to use us. And then when we move forward, there's more and more commercial partners. And overseas now, we got payment partners such as Gcash and Dana that's actually using our database platform, right? And very quickly, the way it works for us is that it's a distributed architecture. So every time you deploy an ocean-based database, even for a community edition, we can do it in one instance now, but it's basically, you need to have 3 nodes, and it's a cluster. And we can separate, have different tenants, and each tenant is an individual database. And you can decide like which of these tenants, which one will be allocated as a leader. So leader means that this will always drive the whole cluster for the read and write requirements. And when you want to write to the database, you're going to transact, you will always hit the leader. But if you don't have, you have eventual consistency, you don't have strong consistency requirements, you can always ask the system to direct the read to the followers, right? And then you can decide how you want to run it. And another really unique thing for us is that we are able to do real-time compression as well. So it's adaptive compression. So when you're doing transactions and you're storing data into the database is decide, okay, what kind of data type this is, and apply a different kind of encoding or compressions into the database. So it's very common that my customers say, if they go from MySQL, they have a 10 terabyte database, and when they go to ocean-based, actually it's only 3 terabytes because it's fully compressed. So one of the reasons why we decided to go for open source platform is that this is really where the world is heading. Okay, so more and more open source database is getting adoption. And open source database has proven to be a model where the more that the community is using the database, the more stable and more capable that platform is. So the best example for me is coming in from the open source side is Postgres and MySQL, right? Because Postgres now is what, version 15, 16 now? 15, right? And the MySQL now is on 8.0. And it's because the community is pretty strong, and it's increasing the use and also the ability for the communities to point out, where to improve the database, right? So we want to have that capability as well. So we are at the start of a journey of being like as part of the open source community. We started the project on 2021, and what we wanted to do here is they wanted to adopt the best practices for an open source foundation. So we're taking elements from, like, for example, for Apache Foundation, we're going to have a technical oversight community. We're going to have a development group and user group. And what we want to do is that at the moment in China, there's a really strong open source community for ocean-based, but we are also expanding it in overseas. And this is where we are at in terms of being an open source platform, which we started with 3.1, where we open source 3 million lines of code and said, put on GitHub and says, knock yourselves out, the source code is here, you can compile it, you can run it, play with it, and then slowly the ecosystem of surrounding the databases, we opening it up as well, and just want to highlight some of those. It's like, doing data migration, we call it ocean-based migration services. There's also the ocean-based management platform. So this is kind of unique in the sense that I have never seen like any other platform to say I've a management platform come with the open source database platform, right? There's also the IDE. There's a few of the APIs that we are opening source as well, and most important is that we are also integrating with the open source ecosystem. So some of the ETL tools that's open source, we are contributing code into that. For example, for IDE, you can also use dbbeaver. In dbbeaver, if you download the latest version, you'll find ocean-based inside there. And so that's the ecosystem. And then towards like later versions of the version 3, we're also looking at how do we handle like slow SQL, top SQL monitoring, and basically, the ease of use of the open source platform as well. So recently we launched version 4.1, which is really exciting in the sense that, I talk about initially we need to have like 3 different nodes and then this one cluster. So our open source users saying that it's a bit difficult to have that much of resource to do initial testing and development. So we kind of re-architected the platform in order for it to run on a single instance of compute, but it's still a distributed architecture, right? So it still retains our design, but we are able to run it on a single piece of hardware now. Another thing we wanted to do in 4.x, eventually we want to also take on analytic performance kind of requirements for a database, where there are platforms such as Redshift that's really strong on columnar analytics. We're going to put that into our platform as well. Yeah. And most important also, we continue to improve our capability to automatically distribute the transactions and the data query requirements towards the node itself, so that you don't have to do it yourself. Yeah. So in essence, what we wanted to do is to really share, to really go for standardizations. We want to be the MySQL of the distributed database, right? So there's no such thing at the moment. There's still quite a lot of platforms available for the distributed database side. Relational distributed database, I think we're kind of unique that way. And another thing is we want to scale our user base as well. Yeah. Of course, in order to get adoption, right? We are MySQL compatible. We are fully compatible for 5.7, but we're getting more and more compatibility for 8.0 as well. So by the end of the year, we expect to have a full compatibility. That is our GitHub. And most important of all is that this is not a new database platform. This is a platform that's been in production for quite a while now. Okay, so in order to start with the Open-Based Community Edition 4.1, right? Here is the documentation. You can come in and take a look at, what is Ocean-Based about, what are we doing in the open source space and our community edition. And there, I apologize, at the moment it's still written in Chinese. However, if you go on here and you find, that means a community edition. You can download the x86. The ARM version of that is ARM specific, probably through China, but what I'm going to ask them to do is to also validate on ARMs in the international market as well. For example, AWS Graviton, right? So we want to validate that. So I'm going fast because I think I'm just okay. Great. So thanks for that. I'm just going to go back here so that you understand like what's the ease of use and if you have any questions so far. Great. Technical discussions.
What consistency guarantees does it provide?
Consistent guarantees. So by default, it's eventual consistency, right? So there's a leader, there's 2 followers. We use Petzold's algorithm to ensure that the data has high availability and also make sure that they're reliably replicated. But there are 2 modes to do that. One is eventual, right? So that you can use the followers for reading. But if you want strong consistency, you can define that you want strong consistency. So either you go directly to the leader, which of course you have strong consistency, or you actually delay the reader nodes a little bit to make sure that they're all fully consistent as well. Yeah.
I have a related question.
Okay.
So suppose I want to use this for financial transactions. I need strong consistency. Mm-hmm. How consistent are the backups?
How consistent are the backups?
Like if I take a backup of the whole distributed cluster, mm-hmm. Is there the possibility that different parts of the cluster will be at effectively different points of time when they get backed up, or do I have a completely guaranteed stable snapshot of all nodes?
It's going to be completely stable snapshot because we are only taking the snapshot of the completely stable and consistent data as a backup.
Okay, that's cool.
Yeah. More questions?
Yes.
Great. Yes. Question, please. Yes.
Hello. Yeah.
Yeah.
I just want to ask, how is it comparable to like a CRM,
How is it comparable to what? Sorry.
like a CRM, like a customer relation management?
We can definitely power CRM, but but CRM would be like
How do you
Salesforce
differentiate?
and so on, right? So sorry.
Are you asking how easy it is to run a CRM platform on it?
Oh, very easy. Because
Okay.
if you can run it on MySQL, you can run it on Ocean Base.
So
What's my selling point? My selling point is distributed transaction, financial transactions. Yeah, and it's not very common for a relational database that's distributed, scalable, and handle financial transactions.
Yeah.
Yeah, so it's commonly like but for financial transactions, I would use Postgres for that because it's pretty good. Yeah, we use Oracle for that, so SQL Server for that. But those are monolithic databases. They are not designed to be distributed. Yeah. Uh-huh.
Yeah.
Okay.
So next question. Well,
Yep. You can call it me or download it and give it a try.
there's
There's more.
one more
Great.
question.
Yeah, I have a question. I think I read it somewhere that you have Ocean Base and then you have PolarDB, also from Alibaba.
Oh,
and
right.
I think there's also something called in-memory something. I forgot the name. And what are all those differences between? those?
So first off, we are part of the Ant Group, right? We are kind of a sister company with Alibaba. So Alibaba themselves has also their own database technology as well. So think of us also in AWS is the same. So AWS also have their own managed database services, right? We do from a commercial side, we do sell our services on the AliCloud, right? We also sell it on AWS as well. So we have multi-cloud. So the difference is that for all these different services, whether it's PolarDB or whether it's Aurora, they're always specific to a particular cloud. So you can only use it on that cloud. You can't really use it on somewhere else. So whereas we are kind of different, we really want to be a standard for distributed database. So you can just use us on anywhere you want. Yeah, we are more like we are competitors, if you will, right? Not really competitors, but at the same time we are, right? Because we are competing in the same space.
I have one more question, then I'll hand it over here. Let's talk about like rebalancing data, because sometimes with some distributed systems, they tend to be a little static. If you're writing a lot of data, maybe it mostly ends up going to one node for one reason or another. How are you able to rebalance things if one node becomes a lot more full than another? If so, could you explain that a little bit?
So it depends on how you want the database to behave. So if you let the database do the automatic partitioning and balancing, so the database will constantly look at the different nodes and say, am I hitting one of the nodes really, really hard? Because sometimes you got hot table problem, right? Where one particular node, because of a kind of transactions or a region, let's say in Singapore, Orchard is suddenly really, really hot, right? Then that particular node suddenly get a really hot usage. The CPU, I/O will all go up. So you can manually say, okay, for that node, you want to split the data, and it will automatically be done automatically by the system. Or you can actually say, if the system monitors that and says, there's a hot table issue here, we're going to split the data as well. Yeah, so that can be done by the database, and that's why we kind of not having that type of problem, because even if you use something like a sharding, you use something like DynamoDB, that's exactly the problem with DynamoDB. If you hit a table really hot, that partition dies. Yeah, which is a common problem. Yeah.
So the question is around the edge computing, right? Ocean Base and edge computing. Do you have any use cases that you had seen in your experience?
Actually, most of my customers want it to be in country. right? So like if you go to Malaysia, you go to Indonesia, they actually they don't even want to talk about edge computing. Is that you need to be there. It's either you're in the data center or you're in a public cloud that's in the country. And if I have customers that says I need to deploy on the edge services, which I'm talking to the edge computing service providers as well, you can deploy the database at the edge. Right? It's not an issue at all. Yeah? Okay. Do we have more? I love the question.
Yeah, I'm sorry if it sounds like two questions within one.
No.
But first of all, may I ask you about requirements for the latencies between different availability zones? And do you support multi-regional installations? When I say region, I mean like all our latencies.
One in Singapore, one in Japan.
Exactly. Asia, Europe, etc., different continents.
We don't, well, personally, I think that's an impossible task. That's one. Second is that within China, we actually do that. So within China, you actually do like in different places like Beijing, Shanghai, or Guangzhou, which is pretty far. Anything that's on fiber and under 50 ms, like the latency must be under 50
so
ms.
below 50 milliseconds.
Below 50.
15.
Below 50 ms.
Oh, 50.
50 ms.
Oh, all right.
Yeah, below. Yeah, I know where you're going with that. I know where you're going there. So a lot of these distributed systems, we use synchronization. We use clock synchronization. In fact, your clock must be like fully synchronized.
Yeah.
Even Spanner needs to do the full synchronization as well, and they have one of the most accurate clock on Earth, right?
Okay.
Google have the hardware to do it. We have the same requirement because we are distributed systems.
All right, and we have time for one more question.
I don't know if you mentioned before, but I'm looking at the licensing. Did you mention the licensing? Because this says Mulan 2.0. We're not very familiar with the Chinese versions.
Okay, first off,
so maybe you can clarify.
Great question, because I'm expecting that one. I asked the same question because I started just 3 months ago with them. So the Mulan license is very similar to GPL version 3, right? So it's an open license. You can use the code, but your own code needs to be open as well. It's as simple as that. And you can include the Mulan license in your own licensing as well. It's kind of like what Spark is doing. So if you look at Spark's licensing, it's that, I'm licensed under Apache license version 2, but then these are all the open source licenses that I have as well. So Mulan can be included that way too. Yeah. So no issues.
Okay, thank you very, very much for this wonderful talk. Now we have, I think, a brief break, and talks will resume in about 15 minutes. Thanks. So, quick question before I get started. How much time do you have me to reserve for Q&A? All right, so for our next presentation, we have Pandey Krishnan, and he's going to explain the improvements that have happened in MariaDB over Ultra, I think it's Ultra Table, right?
Yeah.
And how this is improved in relation to replication, if I understand correctly.
Thank you. Hi, good afternoon, everyone. So today I'm going to discuss about the implementation of lag-free alters in MariaDB. Okay. So I work for MariaDB Corporation. So in the legacy alter, how the alters are going to be is currently handled is, so whenever we execute the alter on a master or source, it will be executed fully on the master first. Once the execution completed, then only it will be returned to the bin logs, and it will be flown to relay logs, and it applied on the slave, and again it will be executed on the slave through the slave SQL thread. So during that period, we may face the replication SQL thread will block the replication for that time. So during that time, we will be facing the replication lag and delay in the replication. So when you have multiple slaves, multiple replica for your master, you will be facing a replication lag for on most of your replicas. You don't get the real time data. So to avoid this, in current situation, we are mostly using lots of tools like PTO, Percona online schema change, and then even GitHub has one tool called Ghost, GHOST, and Facebook also has its own tool. There are multiple tools available in the community. So like always, MariaDB comes up with some innovative method to solve this issue, to handle this and reduce the replication lag. So how MariaDB is trying to solve this is, so whenever we start executing an alter table on a source, it will be divided into two bin log. In the bin log events, it will be divided into two steps. So like how we handle the XA transactions, like XA prepare and XA commit or rollback. So how we handle that in the replication, the same method we are implementing here. So yeah, every alter has a two events like start alter and then a commit or rollback alter command in the bin logs. So when the alter is started executed on the master, immediately there is a start alter event returned to the binary logs and sent to the slave at the same time. So in the slave the requirement in the replica is you need to have a parallel replication. So once your event sent to the replica, immediately there is one more SQL thread which applies start executing the start alter command. So it won't block the replication for that time. Once the alter is completed on the master side, there will be an event called commit alter will be logged in bin log and sent to the replica. So once the commit alter is received on the replica, immediately the commit alter command will be applied, and then the table structure will be changed in the replica. Until that time, you cannot see the table structural changes in replica until you receive a commit. In case if your alter fails, you will get a rollback event on the bin log, and the alter command will be rolled back on the replica. So on the next few slides, I am going to see the implementation details, how it was implemented in MariaDB. So for this, we have a variable called binlog alter two phase, which was introduced from MariaDB 10.8.1 onwards. So in the master end, we just need to set this variable before running the alter. So once we set this variable and execute the alter on the master the behavior on the alter on the master does not have any changes. Only in the bin log we can able to see the start alter or commit alter events. So once the alter got a lock and started executing, immediately for example, this is one of the event for a successful alter and commit in the MariaDB. So immediately the bin log will get a start alter command, start alter event on the bin log. That will be sent to master, and in the master this alter will started executing without blocking the SQL threads. So those who are not familiar with the GTAD implementation in MariaDB, the GTAD implementation in MariaDB is a little bit different. We use domain ID and then server ID and then sequence. These three variables which you are seeing like GTAD 1-1000-784. So one is the domain ID, 1000 is the server ID, 784 is the sequence. So for the start alter, you will get the event with the GTAD plus start alter in the bin logs, and then the real alter command will be logged in the binary logs. When you get a commit alter, you in the same binary logs you will get a new GTAD sequence, as well as you will see the ID for which sequence it needs to apply. For example, in this case, you can see above the GTAD sequence is 784. So in the commit alter, you can able to see the commit alter ID equal to 784. This means this commit is for the event which was executed for 784. So once the commit event was executed on the binary log, then only you can able to see the changed table structure on the replicas. So what happens in between when you are executing the alter command on the master, you cancelled or it got failed, what will happen on that case? There will be a rollback event. So in this case, you will get a start alter command, and it will started the alter on the slaves. So once you receive a signal from a master like it got failed or it got cancelled due to some reason, immediately in the master binary logs you will get a rollback event. So that rollback event will be sent to slave, and that alter will be rolled back. So this all steps will be done in the background without knowing to the users. So this is the implementation steps for lag-free alters in MariaDB. Currently it started with 10.8, so still it is in a development stage. So still there are lots of improvements or suggestions from the community is always welcome. And then like already Daniel mentioned about this, the MariaDB bin log from 10.8 onwards, the MariaDB bin log is aware about the GTADs. So the start position, stop position options are already available in MariaDB binlog utility, but previously we can able to pass the lock positions in this variables, but now onwards you can able to pass the GTIDs for a start position and stop positions, as well as you can, the MariaDB binlog utility is more aware of the GTID strict mode as well. So when you are applying your binary logs on any other server, you can still enable the GTID strict mode as well as, and then if you use the verbose, the 3V symbol, you will get a warning for out of order transactions. So which we usually encounter when the replica there is some writes happened on replica, and then when the strict mode is enabled, usually replication breaks with this error out of order sequence. And then there are few features about MariaDB comparing with MySQL. What makes different MariaDB? So we have an audit plugin, and then the system versioning table, which Daniel already showed, and we have a Oracle compatibility mode as well. So you can still create your procedures, store procedures, functions, triggers similar to Oracle syntaxes, and then Spider storage engine, which is very useful when you look for some sharding. You can shard your tables using the Spider storage engine, and then sequence. Sequence is also one of the options available in MariaDB, not in MySQL. And then the hot backup, like Maria backup. Maria backup is a fork of Perconos extra backup. So these are the few additional features available on MariaDB compared to MySQL. Yeah, that's it from me. Thank you.
So any questions? Okay, a couple of them. I will start. Okay.
Hi. Can you elaborate a little bit more about the Spider storage engine? Like, for example, how do you partition? Is it based on hash? Is it based on some other, methods?
Yeah, you can choose your partitioning method. Yeah, custom.
So I have a quick question. So with this two-phase alter table that you have, it seems like you're moving away from this MySQL and Oracle atomic DDL. Does this mean that there's effort trying to support transactional DDL over the case where you could maybe have multiple DDLs and even DMLs that could get rolled back together? Or do you see that never happening? It's just a question of your opinion.
Yeah, I understand. Transactional DDLs? No. For now, I think even in our community there is one MDAO.
Yeah, I think it's a little bit too far off. It's a step to make things smoother, as the case may be, but yeah, it's a big effort, and I how it's implemented in Postgres and that kind of thing, and the tuples, but yeah, it's a big effort.
This is the beginning for implementing transactional DDLs. So.
Yeah. Okay. My question: if you start a alter transaction on the master in a two-phase thing, and the master just totally gets killed, and you restart it, does that mean the slave thread continues on and it's just waiting for a commit that never happens?
Yeah, that is the current behavior.
Yeah. So you just need to manually kill off the thread in the slave.
So it endlessly wait for the commit.
Okay. Next question. Are there any more? So I had one more question that I had written down. I noticed in your diagram you had the fact that before this change, you'd run the alter table. It would run on the source, and then it would run on the replica, and it would block replication. Does that mean that alter tables are logically replicated? That you don't have some sort of physical replication of them, or I mean, you get just what? Oh, so it is a statement. Okay, yeah, that was
Yeah,
my
it is
question.
a statement. Whatever you execute on, the DDLs are replicated as a statement based
Okay.
in MariaDB and MySQL.
Okay, all right, cool. Right. Okay, I was just curious. Yeah. Yeah.
Okay.
All right. Any other questions?
Is there a way to like pause and resume the alter operation?
No, for now, no. There is no way.
All right. Any other questions? Well, in that case, I want to thank you very much.
Thank you.
Interesting presentation, and enjoyed it very much.
Thank you.
Thanks.
The popular things today is native clouds apps, and as well as the Kubernetes and with MySQL. So today we are going through how we do this running native cloud apps with MySQL and provide reliabilities like NoDB cluster and running on Kubernetes. So the first topic tries to explain the cloud native overview, and the second topic that we today to go over is how we deploy MySQL and the reliabilities like NoDB clusters using MySQL operators on Kubernetes. And we will show the demos how we created NoDB cluster, and as well as how to create and deploy, like using Helm chart or a YAML manifest with the Grafana or PHP MyAdmin, and working closely how to do like external names with MySQL. So first, cloud native overview. So what's today people's looking at, and it's like, okay, breaking down the system into pieces and working together closely. So that's people's call this microservices and small pieces and working closely together and then communicate via some sort of the protocol. And what's the very popular is like, okay, people just do it with the RESTful, right? And the microservice terms, and in the old days, people do SOA or some other call in the old days, right? But today, people always talk about, okay, managing the system and by pieces and working closely. And with the microservices, people have a small subsystem and data actually within the small subsystem. And not like in the old days, a big database, centralized database, and everything connects to just one single database. That's why today, many people start to have a small footprint of database, and just like MySQL does. So as the characteristics for these applications on cloud, so people will leverage other services on cloud, no matter this is like, okay, some other AI services like machine learnings, and as well as some other intelligence service or even, okay, loosely coupled integrations, orchestrations, or queuing services from the cloud. And as more deployment, we need easy deployments. Very likely container deployment is very favorable approach. And as all these integrated microservices, they're loosely coupled, and API-based services are RESTful. So on the cloud, how MySQL we are doing? So Oracle Cloud, we call this Oracle Cloud Infrastructures, OCI. We have the point and click, okay, MySQL service. We call this MySQL Delivery Service, MDS. So it is very just easy to use. We can bring this MySQL with different shapes. Okay, all depends what you need on the CPU, memory, and the configuration. It's just handy. It does all this like backup, securities, and things. And the most important thing here is the extensions. We have the Heatwave Auto ML, and it does the accelerations, high performance, and big data. So what it does, MySQL Heatwave Auto ML, it is actually at the back. Okay, we provision a set of cluster machines, and normally it's used to store the data. So the data is not just to store in NoDB on the frontier, but as well as to push, okay, to the back Heatwave cluster. So that facilitates facilities like in-memory code, and it is in-memory analytics, and it is very, very super fast. And there's one more additional things. ML is AI, machine learning. So the data, when we talk about machine learning, is to train, the train as model. So where the data is, likely the database, right? So it's actually in database ML. So we provide this like capabilities in all in one. One set of the solutions as like the MDS, we provide OLTP, OLAP, as well as the machine learning capability and create your apps. So for today, we talk more likely the deployments using container, Kubernetes, and there might be possibilities a standalone MySQL to run as a server using Docker image. It's just simple. And there's also another topologies with MySQL InnoDB cluster, and it can be deployed using MySQL operator, for the Kubernetes. So what today we are going to show you. So the operator, how we do this? So first of all, as the basic MySQL InnoDB cluster, it is not new things. But what we do here is to deploy this, on this more easy platform container, and it is orchestrated in the Kubernetes environments. The three most stable set components, down at the bottom, MySQL 0, MySQL 1, MySQL 2, the three nodes cluster can be deployed, and the routers can be 3, can be 4, can be 2, can be 1. So all of this, if you do it on your own, we have to manage every components by ourselves, as well as the how apps to connect to the routers. So with the MySQL operators, all this just one single command, and we deploy the whole set of the InnoDB cluster of 3 nodes, routers, and also the connectivity, how to manage the up and down and bring one server down and then switch over to the other, bring the data back, all this automatic. That's the operators. So how we do this? So basically, we have the documentations, and you can read the README on the open source projects that MySQL operator is, and we apply as the manifest installation, we apply the CLD, custom resource definitions, that we create the resource, IC InnoDB cluster companies. And when deploys the running engine, MySQL operators as somebody else, to help you, to facilitate all the operations, backup or some other things. And to create the cluster, it's just simple. Create the YAML or actually using hand chart. So here, as the manifest, we create a YAML file and then apply the YAML. We create a cluster name. So second things. So people may also like to use hand chart. So it's also possible with the MySQL operators. So we have the repository and just to use. And install the operator as the somebody engine, to handle the background jobs, the integrations, ground relations, and to install the MySQL InnoDB cluster through the helm chart. And the red text in here, so the TRS view self sign equal to true. So this is some additional, possibly, people may be missed. So I just put it down here. When we create, we can actually set this, because we might not want to provide the certificate. Otherwise, we have some more steps, to provide the certificate in order to create the cluster. So as simply as in here, just to set this to true. So look at this, the demo. So let me show the demos how we do this. To create the InnoDB clusters using MySQL operators. So we are going to deploy these HA models using the latest versions of 8.032 operators. So what's right now, I have already added the repository And that's why I just to look up the repository and showing the MySQL operators what it has. There's two charts in there. One is the operator, one is the InnoDB cluster. So the very first things, we install the operator engines. So we just have install operators, having the namespace, the name, MySQL operators, and create a name. So just done. We can actually look at what has been deployed. So we just look at the MySQL operator and see if it is already up and running. So it is up and running. And then look at the GitHub website. We can actually copy the tags, and here, that's how we do the hand-chart installations for the InnoDB cluster. It is just very simple. Have install just a name, and this actually we use the MySQL InnoDB cluster, and the namespace, just put a name. We have the MyIC01, and the user's root and password super secret, and it can actually be logged in through anywhere. So 3 instances for the server, 1 router instance, and as mentioned earlier, we use self-sign. Okay, so once we have done this, and the server will be created under this namespace, MyIC01. So you can see, okay, it facilitates a lot. We do not need to create specific server 1, server 2, server 3. So with this one simple command, it creates all these servers together, and as well as the routers, okay, and other so-called servers, like, okay, how we look up the IP address, because the IP, so all this is all done. So you can see it is still under the stage of provisioning. So it is on the stage CO2 of T2. So it is initialization of the DB. So after a while, okay, in around 2 minutes time, so you can see that 120 seconds later on, we have 3 servers up and running. Okay, so it is all in parallel, it's being created, yeah, in parallel. And as well as you can see the services, okay, which is actually being created. Right now, the routers created, finish. So there are 4 ports up and running. One is the 3 server and routers, 4 ports. And what we do here is we have the new name called, yeah, we have deployment, and we have the IC, the InnoDB cluster, and which it has 3 online port running, and also the routers up and running. So what next is we try to connect to the bring up another port running MySQL shell, and to connect to the server, and then look up what is happening. So root super secret my cluster, and we try to look up the cluster status. So they are all up and running with the latest versions 8.0.32, and the name right in there. So it is my cluster -0, -1, -2. So let's look at another demos, which is what we are talking about. Like, for example, the Grafana's. Okay, how we do this Grafana's deployments. It is also quite a popular dashboard framework. People may like to use manifest or hand chart. Okay, we will use manifest this time, and how to add the data source. And at the data source, it is MySQL. But one thing is important. This Grafana's or applications run as separate namespace. So it may not know the IP address. Should we just to use IP address, or use a more independent names, what we call external name? Let's show and tell. So here, this is the deployment of the family using YAML files, and we have to look at the YAML file, which is the image graph banners and port number 3000, and we may configure some sort of resource CPU and memory, as well as to create the load balancers so that I can actually log in from external IP address, like through the internet to access to it with load balancers. So what we do, actually, we have this, and we can just to create a namespace of the families and apply the YAML file within that namespace. So you can see I just to apply this YAML file we just create. And as well as you can see the YAML file create different level services, including the family itself as well as the load balancer service. And once we run this to use, and we can look at the Grafana, it is up and running. So still provisioning and getting more and more, and we can very soon to see it. And once we get this to it, what we do here is like how we can connect to the server. So we just look up the IP address. You can see the external IP address, and we just log in, and we can see the cluster IP. Okay, but sometimes we might not want this like IP address. Yeah, we never know. Okay, another day when the server down out again, so the IP address will be changed. But anyway, in here, we can just use the IP address in here to see, it's still working in here. So the rows service egress which we have just created, so and then we say and test the connections works. That's not nice. So what the next is, if we do not like to use the IP address, we want some DNS name, so the my cluster as the service to connect to it. But we are actually in two separate namespace. How can we do this? So what people want to do this is to isolate them by means of loosely coupling and using the service and mean the type external name and connecting to that name, we have to define with the my IC01. So we apply this specific, my custom YAML file, and to define all this like namespace. So if we look at this, we have more names that we can use. So one of which is my cluster. And my cluster is the point routing to the MySQL routers point, meaning whenever there's any switching up and down, it will point to the right server and getting that to use. So that works. Dashboard, and we may get hookups to right specific a schema, performance schema, a specific table regarding like memory usage, something like that. So just take an example. So we add 2-3 columns, allocations, how much memory is free out, and for specific events as well. So on this, we may actually be able to see that. Okay, we have a report. Okay, getting data. So we may try to create this. So all this, and we may actually create another one, select a version, another panels. So within the dashboard, that's actually look up the server name, host name, and as well as port and versions. So once we have this, it is pointing to my cluster as the server name. So what we do here is we may change to primary cluster, to somewhere else using MySQL shell connecting to it and connections to it, and then switch this primary instance to another server. So what's up to this? once we do this, we will have the server and change this to my clusters tool for just an example. So we can actually change it to cluster 2. So what we do here, the server just switched. And if we refresh the page, and what it does, the server connects to this my cluster as the router method here. It connects to the right servers, okay, which the primary server. So we can actually change another time. And so from the application point of view, it is seamless. It is just ease of use and automatic handy. Okay, the last bit of piece I want to show is the way we are using the PHP. So here's another quick demo. When we deploy PHP, my admins to MySQL InnoDB cluster, and last time programmers using YAML, and this time as the services, we may actually do this by HemChart as well. We can put in the PHP my admins, find somewhere else, it's open source, and we have the Binami HemChart, okay, and we have the HemChart creations where we just to set the DB host equal to my cluster. Again, my cluster is the name. So basically, we provisions using the HemChart values, the values between the original and the added. I just put the added, okay, to the HemChart report values to put in the certificates for the connections. So the PHP MyAdmin connects to the server directly as the SSL connections. So I also put the load balancers to enable the browsers from internet what my machines can connect to it. So we can see the IP address and finally we get hookups to the servers. So well, we have the service up and running. So here IP address from the load balancers is 129. Some other things. And we just copy and paste and put it into the page and we will find we log in. But the thing is we haven't yet to put in the external names. That's why when we connect, it fails. Now we go back in here. We need to provide extra. Okay, the reference. Okay, regardless my IC01 and my cluster on my service store. So what we have is against my cluster YAMLs, which has all the external names for the servers. So we just register all this to the PHP MyAdmin namespace. And once we have all this done, we can run this PHP MyAdmin again. So it is just easy and handy. So it is all created. So with this, we just log in again and done. And it is SSL connections. I hope this can go with the questions and see if anybody you have any questions for us. Thank you.
Okay. So for our final presentation today, we have Colin Charles, who is going to talk about deploying Galera clusters and various aspects of his experience on this. Go ahead and take it away.
Oh yes, thank you for coming. Last talk, beer is waiting. We should all go for that. So yeah, do stuff at Codeship, do stuff elsewhere. Done a lot of MySQL for a long time. So, what is Galera really? It's virtually synchronous replication. Some of you managed to stick around to talks earlier about group replication. It's also high availability with no data loss, consistent data across all nodes. So copies of data across your 3 different nodes, for example, no single point of failure. So I think there was an ocean-based talk that said you could reduce the size by 1/3, even though it's distributed, and there's a reason why they do that. Whereas we follow, repeatable read, very consistent, 3 copies of the data, very much like InnoDB cluster. Does quorum-based failure handling, so again, you need 3 nodes, because if 1 node fails, you still have 2/3. Commits with optimistic concurrency control, so whatever's written to basically 1 node is shipped via certificate and then certified before it actually is the OK sent back to the client. It is multi-primary or multi-master. All your nodes are equal. It's actually a core feature of the product by design. So it does transaction conflict detection, and you can issue your basic transaction to any node, though many people do have a proxy in front of it. And it works obviously in clouds without issue. Obviously supports SSL, so in transport as well. No framework is required for automatic failovers. It does do parallel apply, and it's got literally thousands of users. It's still doing extremely well. Of course, you have some trade-offs. So it'll never be as fast as asynchronous replication, which is just committing to the primary, or semi-synchronous, which is primary and at least 1 secondary. So we never will beat the laws of physics. And of course, storage. Storage is going to be tripled. So we have many instances of people across the more than a decade now of deploying Galeras across various companies. You'd actually realize that sometimes people want 5 nodes, 7 nodes, but you're really replicating the data 5 times, 7 times. It's not really like the most practical thing to do. You should really aim for a 3-node Galera cluster, not a 2-node Galera cluster, which actually a lot of people also think they can do and get away with. So there are multiple distributions of Galera. I just want to highlight, well, obviously the highlights. The Codeship upstream variant is the one that actually comes with clone SST as a plugin option. So your SSTs don't happen via extra backup, and I'm sure you've seen some nice presentations about why the clone plugin is much faster. It's kind of like an rsync with enough amounts of locks. So it's not just rsyncing a live data directory. Clone is much faster than extra backup, which I'm sure anyone from Oracle MySQL will tell you. And it's also true when it comes to full state snapshot transfers. And for the non-Galera folk in the room, Galera has 2 forms of state transfers. One is the incremental state transfer, which is something you have if you already have an existing Galera cluster and a node goes away for a period of time. When it comes back, you can get an incremental set of data. It gets like a diff. Whereas the full state snapshot transfer is for provisioning new nodes, because it literally can either rsync a copy over or use this clone method. MariaDB, actually the first to ship Galera cluster in a distribution, and it's included actually. So MariaDB by default is either async, semi-sync, not as a plugin. Galera also not as a plugin. And you obviously get all those amazing MariaDB features that multiple people talked about earlier today as well. And then there's Percona as well. Basis Percona server, it comes with proxy SQL. Now with the operators, it comes with HA proxy. The strict mode is kind of nice. For one, it disallows MyISAM, tables without primary keys, forces you to ensure the bin log format is set to row. And it actually has automatic configuration of SSL. This is maybe the most interesting thing out of Percona XDB Cluster 8. The fact that you probably run a database now configured in the cloud. And I hate to break this news to you, but all MySQL replication happens in plain text unless you turn on SSL. So if you're not turning it on, I don't know what you're doing. So there's some feature highlights, so obviously for Galera. For one, there's things like intelligent donor selection for an incremental state transfer. So it'll find the node that is most compatible to giving you information, plus with less load. PC recovery equals on has been turned on. So in the event that a cluster node crashes, or even if the whole cluster crashes, the ability to have persistent cluster information maintained, not requiring a bootstrap, is much easier. This is actually how many tools nowadays can manage to actually do an automatic recovery of a cluster, because it actually manages to pick up the GRA state.dat file information fairly simply. GTIDs are different in both MySQL and MariaDB, and I think earlier there was a good idea of how you could design the MariaDB GTIDs. Now the good news about Galera is either if you use MySQL or MariaDB, it follows the native GTID of the database server. Pro tip, Galera actually came with its own GTID. Galera was actually the first to come up with a GTID implementation, followed by Tungsten Replicator, where they had this in the transactional history log, followed by, actually, supposedly, it would have been, it was actually then MariaDB and then MySQL. Foreign key support, very good. When I say improved foreign key support, all you were seeing in the error logs were lots of errors when foreign keys were encountered. It turns out that they were just warnings. They weren't errors. Your foreign keys were actually running, we're just stuffing stuff into the error log. So by improving it, we've actually made it less verbose. So that's good. Some new MySQL tables like WSRep cluster, cluster members, and streaming log. Cluster and cluster members will tell you fairly interesting things about your cluster, as well as the members in the cluster. Could be 3 nodes, 9 nodes. And of course, streaming log, I'll talk about streaming replication fairly soon. So this one replicates transactions of any size. So before Galera 4, your maximum transaction was 2 gigabytes. So if you were doing a low data in file, and if you exceeded 2 gigabytes, it would fail. So this would, and you could actually control it. Typically, people were telling you to always do it much smaller. But with Galera 4, you control it via streaming replication. What that means is you can actually ship 10,000 or 20,000 rows across the network, even before the transactions are actually applied. But they're actually already there, just waiting to be committed. So it's much better than shipping gigabytes of data and then finding that you have to do a rollback later. Poor networks. This one is something that I think Galera has benefited a lot from learning from group replication and InnoDB cluster, because by default, the Paxos-based protocol that group replication uses actually handles poor or slow networks reasonably well, whereas Galera had to learn from Galera 3 to 4 about making this better. So we can handle much better network that will drop poor without sacrificing your data consistency. So this is another benefit of having open source out there, right? It's that everyone benefits from each other. So the reason why I put this slide here is for the sole purpose that you can actually get some of these features inside of open source Percona server. Black box for error logging is actually kept inside, is actually open source in Percona server. Non-blocking operations for online schema change, also open source inside of Percona server. And I believe it wouldn't take much longer for Percona to also port Gcache encryption to ensure that your data directory is fully encrypted. So no one here talked about the fact that MySQL supports at-rest data encryption.
and it is fully at-rest data encryption. So your entire varlib MySQL is encrypted. And in our early morning talk today, we did allude to the fact that you could use Vault, HashiCorp's Vault, to actually do key management. Oracle has solutions like KMS. There's also Amazon's key management solution that MariaDB ships. So multiple ways for you to have key management, but also ability to encrypt your entire data directory. But if you happen to use Galera, the Gcache is the only thing not fully encrypted, and honestly believe a pod's coming fairly soon. The biggest hurdle that I've actually heard from most people in terms of wanting to upgrade is we don't want to migrate to MySQL 8. Most people want to stick to 5.7 or are MariaDB users, and they just say, oh, we don't want to migrate to MySQL 8. If you are still using MySQL 5.7, I mean, you probably shouldn't be sitting here any longer. You should literally go out there and plan how to migrate to MySQL 8, because not migrating is no longer an option. So most common setup that I've seen that we would obviously recommend as the minimum viable setup is 3 cluster nodes in one data center. The other common setup that you see is the 9 cluster nodes across 3 data centers. These 3 data centers can be Singapore, Frankfurt, New York, no problem. Presumably you're running this inside of Amazon or Google Cloud. If you're telling me you want to run across clouds, that the latency will hurt your application eventually, especially if it's insert heavy. Because remember, database operations are actually local. You can actually segment database operations. So what happens with a 9-node Galera cluster is that if you write to Singapore, it'll write to the 3 nodes in Singapore, segment 0, and then it'll write to 1 elected node in Frankfurt, segment 1, and 1 other elected node in New York, segment 2. And this actually means it doesn't send the same transaction across 9 times, but only 5 times, and 2 times over the network. So it's kind of efficient in that sense. So and the latency penalty, as you know, is minimal because it's just certifying it before anything. And of course, some people also use this with asynchronous replication. Though I like to reference Marco Tusa's blog post and his YouTube video about why running it across multiple data centers may not work out well for you, and you may prefer asynchronous replication between 2 data centers. For one, we find not everyone really has 3 data centers. Many people are happy with disaster recovery in 2 data centers. So telling them to actually find another data center is an expensive operation. Telling them to throw up another 3 nodes, expensive operation. So sometimes people do async across 2 as well. You must always remember the weighted quorums. So this is why you don't have a 2-node Galera cluster. You don't have a 4-node Galera cluster. You don't have a 6-node Galera cluster. Odd numbers are good. So realistic common setups that I've seen over the years. Yes, there is a 2-node cluster. No, you should not run it. 3-node cluster across 2 data centers. Usually this comes from the telcos. They say, we have very fast interconnect between the 2. We can do this. Okay. As long as you know what happens when it fails. 3-node Galera clusters across 3 data centers. Not even segmented, so it's one Galera cluster with latency across 3 data centers. Not the best idea. 5 nodes spread across 2 data centers. Again, you got the 5-node thing correct, but the 2 data center thing not quite correct. So actually, I'll introduce you to the arbitrator daemon after this. And well, this one's production, 7-node cluster in 1 data center with async secondaries hanging off of 1 as well. It's a big e-commerce site. Typical things you probably need in your my.cnf. These are pretty basic. Of course, you have lots and lots of nodes. Remember to segment things. This is what most people forget to do. I actually have a few more tips for you. So make sure you have segments for each data center. You can actually increase the replication windows, make it like longer timeouts, even timeouts to above the max round trip time across nodes. You must monitor flow control, which is everything with FC. That's what you look at. you can also actually run Galera cluster on a dedicated network. Because Galera cluster is port-based, you can actually route traffic to separate network interface cards. So port 3306 goes through ETH0, and the Galera ports go through ETH1. It's also doable. In fact, NDB cluster does this quite often, actually. And then you need to play control to, flow control. This one's being renamed, by the way, because, we can't call it master slave any longer in 2023. We must be politically correct. Causal read timeouts, EVS, auto eviction. Your Gcache size needs to be set, otherwise you will not get an IST, an incremental state transfer. You need to open up the port for your incremental state transfer, otherwise you'll always get a SST. You need to make sure that if your methods are like rsync, IC Linux is not going to stop rsync. You should probably have retry autocommit set to something like 5, 8. This is like maybe the most basic thing I see most people not do, is that they don't set the ability for your application to do autocommits, so that when there's a cluster conflict, there's a victim transaction and a priority transaction. At least this will help you retry up to 5 times, which I have 5 minutes left. I'll be on time with questions. Then, MySQL likes to give you options to shoot yourself in the foot, like certified non-PK equals 1, for example. There are actually other options that I didn't put here, like ignore split brain, things that you should never use, really. If you don't use primary keys in MySQL with InnoDB, guess what happens? You get one inside anyway. Yes, it's internal. So it'll actually cause problems with cascading deletes and so forth. So really, use primary keys. In fact, MariaDB is a little smarter in that sense. They've got this force primary key option that you can actually put inside your my.cnf. It's kind of nice. It'll force the developers to be smart. This one, WS replicate myISAM. It should really always be 0 because you should not be using myISAM. However, if you use MariaDB, you may find that this option does exist because MariaDB's temporary tables are also in ARIA and system tables. So this replication needs to also replicate. So it's more or less, I'd say, experimental, but the documentation may say it's usable. The answer should be switch everything to InnoDB. So if you have 2 data centers and you want to still run this way, the best way is to have a Galera arbitrator node. So it can sit in Amazon, DigitalOcean, whatever. And if you have an even number of nodes, you can't afford more than 2 in one data center. Have the arbitrator daemon running on maybe your application server. All it does is it looks at the traffic and acts as a voting mechanism. It doesn't actually have to do anything, doesn't store data. So it's actually a reasonable solution to fake another node. You probably want to use some proxies. I think we talked about proxies today morning quite extensively. So there is Galera load balancer, like HA proxy. They're both level 4 load balancers. I highly recommend Proxy SQL or MaxScale if you can succumb to the license fees. So really just go use Proxy SQL. It's pretty good. It's open source, GPL v3. Actually supports native Galera and group replication host group types. So you can actually reconfigure things within the Proxy SQL using what looks like SQL, really. In terms of backups are good to have. You should use Extra Backup or Maria Backup. But if you want to provision new nodes, Clone SST is actually really good. I'm surprised Percona has not managed to port this yet. I mean, it is open source. It is a plugin. It will get ported soon, I'm sure. It cannot run in MariaDB because MariaDB's architecture is completely different from having Clone. This argument has already been had with Monty before. It takes a lot of work. So common setup and runtime issues, SLinux, firewall, DNS might be a problem. Everything could be a DNS problem, really, so maybe you should just use IPs. This one, don't start and restart 2 nodes at the same time. People do this more often than you think, and it actually brings your cluster down. Also, if you have really long running queries, maybe that's what an asynchronous replica is for. MySQL has this thing called max execution time you can use. MariaDB, you can just kill queries. These functions, not that important. Lots of adoption, not so important. Plenty of things to improve on, probably not so important, but you can look at the slides later. Lots of reading. I've given you plenty to read. Yeah, really. I'm open for like 1 minute of questions for whoever is still here.
So, any questions? Otherwise, I can ask one. All right. I have a quick question.
I can go back.
Actually,
Find it.
sorry, I've managed to forget my question. I will take it over to Mehboob and have
All right.
him ask one.
Achievement unlocked. He's forgotten his question.
So I mean, the thing about shooting yourself in the foot is that that's in the name of convenience, right? Just make it easy.
Yeah, that's true. MySQL is always about making things very easy for the end user. I think to be fair to MySQL, we suffered a lot less recently compared to say MongoDB. With people going, oh, it's web scale, blah blah blah. They got web scale eventually.
Mm-hmm.
Just that, and I mean, if you were around long enough, you'd remember that people used to laugh at the MySQL documentation that said, "Hey, you don't need transactions. Yeah. You can work around it."
Yep.
You said the same thing back in the day.
So I do remember my question. Let me just turn that off.
Is there a bomb going
Oh
on?
no, that was my timer. I do. So you mentioned telcos sometimes running 3-node clusters in 3 different data centers.
2 actually.
Okay. The question I have about this is that just because you have fast interconnections doesn't necessarily mean that they're low latency.
Mm-hmm.
So have you actually had problems with long, fat pipe cases in those cases?
Of course.
Okay.
Slow response time, and we go, well, obviously it's your setup. What do you expect?
All right.
Laws of physics do apply.
Yeah.
We can't fix them.
All right.
But obviously, for some people, asynchronous replication is probably the better choice, or even semi-synchronous.
Absolutely.
Is a better choice.
But you can run into long, fat pipe problems even there.
True.
Where, yeah.
And I think Facebook was a large proponent of semi-sync, as was Google.
Mm-hmm.
And even Facebook realized that at some stage, semi-sync wasn't enough for them. Let's go Raft.
Yeah.
But you were not here in the morning when we talked
Nope.
about that. Yes.
Nope. All right.
Yes. Okay.
All right. Well, thank you very much.
Your time.
Fascinating talk, and yeah.
Thank you.
Thanks.